be all proof.
Fields and the renormalized
Just try me if you think I'm bullshit.
To rewrite the Lagrangian in terms of these renormalized quantities with things left off. With things left over, and we take all the leftover parts and sum them up into counter terms. I will now write a horrible expression on
It's over. Everything starts from now. We all go down unless we stay together. Ain't no one man above the crew. You know that shit.
Minus mu squared over 2 phi prime squared.
Crazy, man.
Then there'll be some coefficient. Then there'll be some coefficient.
When you said that last time, I was kind of tripping, right? But now...
Then there'll be some coefficient.
I am crazy.
Right.
But you know what else?
Right. Then there'll be some
Get
coefficient.
fuck.
And finally, the constant will be changed. A, B, C, D, E, and F are given simply by comparing these two things and constant prime in terms of constant. Simply by comparing these two things, the force of this to be equal to this. Obviously, we can do it. That's the only choice to say we have said. Based on consistent prime, you have to have a constant phi that is a phi squared term again. If you are interested, Now, the general stratagem is this. Please notice that all of these coefficients are going to be things at least of order g, and this coefficient f is going to be at least of order g squared because of how we've defined things. And therefore, our stratagem will be to treat these as we treated the counter terms before. That is to say, to compute everything, treating A, B, C, D, E, and F as free parameters, and then to fix A, B, C, D, E, and F by imposing our renormalization conditions, the conditions that define the renormalized mass and the renormalized scale of the fields. Notice we have just enough conditions to do this. If we ignore the constant and constant prime, we have 6 counter terms, A, B, C, D, E, and F, and we have 6 renormalization conditions. This one is automatic, so we don't have to impose it, and this one, that makes 3. The physical masses must be mu squared and m squared, that's 4 and 5, and we have the UPAP committee's definition of the standard experiment that defines G, that's 6. Okay, so we systematically go out, order by order in perturbation theory, treating A, B, C, D, E, and F as free parameters. To any fixed order in perturbation theory, we impose the values of A, B, C, D, E, and F by asserting our 6 renormalization conditions. And then we determine A, B, C, D, E, and F self-consistently as a power series in the physical coupling constant, and we have achieved our desired end. We have turned a stupid, although in principle valid, perturbation series for the wrong Green's functions in terms of the wrong coupling constant with the wrong masses held fixed into a systematic perturbation expansion for the right Green's functions in terms of the right coupling constant with the right masses held fixed. Any questions? Now we are almost ready. Almost ready means we'll get to it next week. We are almost ready to begin doing computations to see how this formalism works out. But there are two questions which we have to consider first. One is by considering this term as a counter term as part of the interaction, we have introduced a derivative interaction, and we've set up our whole formalism for non-derivative interactions. So there's an awkward but necessary technical point we have to investigate. What is
Yes.